Right, so all of these are going to be done by factoring. Take a peek at number 1. First step would be to do what? Greatest common factor is a x. Let's pull it out. So x times x squared plus 3x minus 4. First step in factoring. Always, if there's a greatest common factor, take it out. Is that a perfect square trinomial?
No.
No. That's not a positive 4 back there. Remember, perfect squares have to be positive. Doesn't mean it's not factorable, so we'll give it a shot, but it's just going to be good old-fashioned factoring. It's not going to be anything special. So we need two numbers that multiply to negative 4 and add to 3.
Positive 4.
Well, that wasn't so bad, except we're not done. And every once in a while, somebody stops right there. Remember, it said find the real and or imaginary solutions by factoring. So you're supposed to use factoring to find them. What's the 0 for that one? How about that one? And that one? 0, negative 4, and 1. The 4 looks kind of awkward. There it is. If I just see answers over there and there's no work, I can't give you any credit. It said you have to do it by factoring. It's specific. You have to. 2 has been the scary factoring for some of you. Hopefully not so much anymore. We've done a lot of practice with it. So there's no greatest common factor, but what do you see? Couple of cubes. Okay? So this would be the sum of 2 cubes formula, which means we've got something with 2 terms in it, and then another one with 3, but we have to remember what. So what goes in the little 2 term? A plus b, exactly. This is a cubed plus b cubed. There's got to be at least one a plus b in there somewhere, for goodness sake. Okay, let me think logically. To get a cubed, a is going to have to be multiplied by a squared. It has to be. To get b cubed, b is going to have to be multiplied by b squared. Has to be. Now, think through logically. What has to happen with the middle term? Has to cancel. So what does its sign have to be? Right, because this is a plus. And you have the formula. Just thinking through it logically. All right, well, in order to use that formula, we have to know 1/100 cubed. So let's see, this was something cubed, and 27 was something cubed. So what they cubed to get x cubed? X, yeah, okay, easy one, right? What do they cubed to get 27? 3. If you didn't know that, do you know how to find the buttons on your calculator to get that for you? It's under math, and it's number 4. It's cube root. So if you forget that, or if it's not a 27, maybe it's a bigger number, and you're like, I don't know what that is. 64 is 4 cubed, all of those things. Just use that math number 4 button. Now what we just found was A and B. A is x, and B is 3. Now we're very carefully going to put it into this formula up here. So this will be x plus 3 times x squared, sorry, put the plus there, plus u, minus 3 times x is 3x, plus b squared, 3 squared is 9, and we want to know when it equals 0. I think we already have one nice 0. What's the nice 0 from that little binomial? -3. 1 down, 2 to go. Problem. You think of 2 numbers that multiply to 9 and add the -3. Not going to happen. So typically, what have we been using?
Quadratic.
Exactly. Quadratic formula. So let's see. I might have to do that somewhere else because I'm running out of space. Give it a try. A is 1, B is -3, and C is 9. So x equals negative of -3 is 3. Do you all remember the sum? X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So we've got our negative of negative 3 plus or minus negative 3 squared is 9 minus 4 times 1 times 9 all over 2 times 1, which is 2. Simplify what's under the radical for me so we know where to go from here. And I'm going to have to do this up here so we can look at it. What's under the radical, everybody? Negative 27. That sounds like that's going to take some work. So square root of negative 27 is the square root of negative 1. How else can we break it apart? 9 and 3. So we've got the square root of negative 1, square root of 9, and 3. What does that simplify to? 3i square roots of 3. So we're going to substitute this in for square root of negative 27. And check for one last step. That one last step is, can we simplify that? 3's and 2's not going to have anything in common other than 1. So our answers here would be our first negative 3, and then 3 plus or minus 3i square roots of 3 all over 2. We have all 3 answers. That's kind of one of the last things you want to do is take a peek and say, wait a minute, did I find them all? No, we need all of those answers as we go through it. That's sometimes the toughest problem for people on this test. You know, it's that cube formula and remembering all of that. And my mouse won't let me mess with the word, so I'll have to go back here in order for it to slide up and down for me. Oh, it's going to make me erase first, isn't it? Yeah, I'm going to have to erase first. Let's be orderly. This line. Okay, computer. Everything's fine. Be a good computer. Let me slide. It's like the mouse is stuck. There we go. Come on. Oh, come on. You're being good for a second. There you go. Come on, a little bit more. Little bit more. Fine. I'll just use the arrow keys. You can be as ornery as you want to be. There. Just trying to be nice. Wasn't going to let me. Number 3. Greatest common factor. X out everything? Not everything. Well, what's so special about that one? Yeah, 4 terms. Factor by group. We've got to trick our brain. So let's start tricking our brain. What can we pull out of x cubed minus 2x squared? An x squared. How about 3x minus 6? 3. Ooh, that's good news. We did get the same thing. So it was there. We just couldn't see it. But really important is going to be what goes in the other one. What does go in the other one? X squared plus 3, exactly. Okay, we got one nice and easy one. That's this one right here. What's the 0 for x minus 2? 2. The other one's going to take a little bit. A lot. Little. X squared plus 3 equals 0. How do you solve that? How do we solve x squared plus 3 equals 0? So x squared equals negative 3 square root plus or minus what? How do you simplify the square root of negative 3? I square roots of 3. Did we get them all? How many answers was it supposed to have? 3. 1, 2, 3. Don't forget the little 2 we had up there. Oh, that wasn't so bad. 4 just looks wrong. What's wrong with 4? Exactly, it's not equal to 0. Let's add that 81. And that 81 is making me very suspicious. Because what's special about 81? It's a perfect square. Maybe, just maybe, this is one of those perfect square trinomial thingies. That's x squared squared. That's 9 squared. If we multiply those together and double them, do we get 18? We do. Ooh, that is good news. So we just have to figure out what goes in there. Oh, we already did figure that out. This is x squared. That's a 9. And we just have to look up a little bit to see what that middle term should be. It is a negative right up here. X squared minus 18. Hey, wait a minute. I think we can factor that too. What does x squared minus 9 factor into? X minus 3 and x plus 3. It's a difference of 2 squares. Cool-a-rooney. So the zeros are what and what? 3 and negative 3. Oh, problem. That's only 2 answers. How many were we supposed to get? 4. Where are the other 2? Not imaginary this time. Do you remember multiplicity? See this little 2 right here? That tells us this one occurs twice and this one occurs twice. That means if we graphed this, it would bounce at both of those numbers. And remember, when it bounces, it counts twice. It's like it hits it and it bounces off. So each one of these is a repeat 0. They both count for 2. So 2 and 2, we get 4. There it is. But definitely, when you are done with these, ask yourself, did I find everything? You know? And then double check with your graphing calculator. See, it bounces at 3 and negative 3. I told you it did that. It better do that, otherwise we know we did something wrong. Not taking the calculator away from you. You're going to have the whole class period to work on 12 problems. The very least you could do is double check your answers. X to the 4th minus 18x squared plus 81. There it is. You can see, hey, it's bouncing at those 2. And you could use your table just to make sure. Oh, look, negative 3 was good, and 3 was good. Good stuff. No one doing these right. That's what you want to do. So now, oh, well, this time I'm not going to let it get. I will erase an arrow. Notice the directions for number 5. Use a graphing calculator to find the real solutions of the equation. Where necessary, round to the nearest hundredth. How many decimal places is 100? 2 decimal places. So let's get her in there and let's see what happens. This you need to practice. Everybody grab a graphing calculator right now and get this little monster in there. X to the 3rd minus 4x squared minus 7x plus 10. I'll wait for you. Zoom 6. Now, normally, I would go to the table and find them, but I know the ones on the test are not going to be from the table. They're not. So we're going to use Blinky to find these to make sure everybody knows how to find Blinky. So if my graph looks like this. I have to remember that out here, this is left and this is right, because it has to be above and below the x-axis. So second trace, number 2, zeros. And I'll wait for Blinky to get over there. Now he's below. Enter. Get to the right. Enter. Enter through guess. Oh, Blinky, you're my hero. -2, 0. I'm not done. There's 2 more. And here's where you get turned around backwards. Because for this one, it's going to be left here and right here. And it's going to yell at you. It'll say no sign change or sign change error or something along those lines if you do it wrong. So then you'll know, oh wait, I did it backwards. Second trace, number 2. Linkster is above, enter. Linkster is below, enter. 1, 0. And then it goes back to normal for this one, where left is below and right is above. Second trace, number 2. Linkster's coming back up now. Where are you, Blinky? There's Blinky. Enter, enter, enter. 5, 0. Like I said, these 3 you could see from the table on the test. They won't be table problems. They'll be goofy. So you want to be able to find those zeros with the graphing calculator. I think that's a good place to stop. Does anybody want me to make up another one of any of those right now? I mean, there was one where you thought, boy, if I just had one more of these, this would cement it for me. Okie doke. Well, the lovely Jessie will be handing out your little assignment here. And again,